Welcome back everyone, today we are going to make some potassium hypochlorite. First questions first, why are we not making sodium hypochlorite? Well, that's because I've still got a big canister full of sodium hypochlorite and wanted to make something different. For this, 34.55 grams of potassium carbonate, 35.75 grams of calcium hypochlorite and distilled water are needed. The chemicals were weighed out in advance. This is the calcium hypochlorite and this is the potassium carbonate. The calcium hypochlorite powder was put on top of a magnetic stirrer and approximately 178.72 milliliters of distilled water were added. The majority of the calcium hypochlorite should actually dissolve, and a few lumps that aren't, well, we will just leave them be. To the potassium carbonate, approximately 71.28 milliliters of distilled water were added. As you can see, a few lumps of calcium hypochlorite didn't dissolve, but this should not be a huge deal. Because I didn't know if this reaction would be exothermic, an ice bath was used. If the reaction gets too hot, the potassium hypochlorite will inevitably decay. This wasn't the case though, it would probably be enough if the reagents were simply cooled down using a fridge in advance, at least the potassium carbonate. Even after messing around for some time, we didn't get the magnetic stirrer to do its job. Some water and ice were removed until it finally decided to work. But because of the distance between the beaker and the stir plate, and well, I destroyed my last crystallization dish, we had to use a glass stirrer to stir it efficiently. Afterwards, over the course of approximately 2 minutes, the potassium carbonate solution was added to the beaker. It doesn't look like anything is happening, but there's actually a reaction taking place. The calcium hypochlorite reacts with the potassium carbonate to form potassium hypochlorite and calcium carbonate, which is insoluble in water. The calcium carbonate crashes out and the solution becomes really thick. In the end, the thickness of the solution prevented the magnetic stirrer from stirring anything. Therefore, the use of a glass rod was absolutely inevitable. Vacuum filtration was set up. For strongly alkaline solutions you should definitely not use a filter paper, but I don't have any alternative, so we decided to do it anyways. And yeah, a bigger filter might be advisable, but we don't have one at the moment and we have to work what we've got. The calcium carbonate that we filtered out was simply scraped into another beaker when the funnel filled up. And there you have it. Potassium hypochlorite with some calcium carbonate that still made it over into our filtration flask. To get rid of the contaminants, the potassium hypochlorite was transferred to a freshly cleaned beaker. Here you can have a look at the potassium hypochlorite solution. The solution has a yellow-greenish tint to it. Because a few clumps of calcium carbonate made it over, we decided to filter the solution again. By implementing the second filtration step, we managed to get rid of all of the calcium carbonate contaminants. Then we measured out how much potassium hypochlorite solution we got. It turned out that we collected a total of 164 milliliters of potassium hypochlorite solution. In theory, a maximum of 250 milliliters of water containing 45.275 grams of potassium hypochlorite would be obtainable. This would correspond to a 15.3% concentration of potassium hypochlorite in water. If our solution had a concentration of 15.3% potassium hypochlorite, we would be left with a 65.6% yield. To show you that this is indeed potassium hypochlorite, a piece of pH strip was added to it and you can see that the solution is strongly alkaline. We don't have the equipment to perform a titration, but I can tell you the density of this stuff using one of these. This is an aerometer or a density measuring thing. I didn't find any table that has the concentration of potassium hypochlorite correlated to the density of it, but if you happen to find one, I would be grateful if you shared it with me. To measure the density, we filled up our measuring cylinder with some stuff of our solution and we simply put in the aerometer. Does it float? Yeah, it floats. And our solution has a density of around 1.1 grams per cubic centimeter. 1.1 grams per cubic centimeter. That's the density of the solution. For the fun part you probably waited for, this stuff is bleach. Not common bleach, it's also known as iodiavel, but we are going to compare it to sodium hypochlorite solution that is actually pretty strong and not used for bleaching clothes but for chlorinating pools. To do this, a few drops of sodium hypochlorite are placed onto a black piece of cloth on the left side, and a few drops of our homemade potassium hypochlorite solution were put onto the right side. The effects of the highly concentrated sodium hypochlorite solution became visible pretty damn quickly. But after a few moments, the effects of the potassium hypochlorite solution became also visible. If you have any idea what we should do with it, write it down in the comments and I'll look into it. But keep in mind, we are not going to make potassium chlorate. If you liked this video, make sure to drop me a like and consider subscribing to my channel for more stuff like this in the future. I wish all of you a nice day. Until next time.